given the polynomials f of x and g of x, where fx is in terms of a and gx is in terms of b, both a and b are constants. Part A, x plus 3 is a factor of fx. Find the value of a. If x plus 3 is a factor of fx, we can set x plus 3 to 0, then x is -3. And since x plus 3 is a factor of fx, then f of -3 must be 0 from the factor theorem. We replace x with -3 into fx. We have 4 -3 to the 3 plus a -3 squared plus 8 times -3 plus 15. This must be 0. That will give us -108 plus 9a minus 24 plus 15 equals 0. Simplifying and rearranging, we have 9a equals 117. Therefore, a is 13. Part B, we are given that the remainder is 40 when g of x is divided by x minus 2. Setting x minus 2 to 0, we have x equals 2. From the remainder theorem, g of 2 equals 40. We replace x with 2 into gx so that we have 2 squared plus 2b plus 18 equals 40. And simplifying, we have 2b equals 18 so that b is 9. Part C, with a equals 13 and b equals 9, we need to factor fx minus gx completely. To factor fx minus gx completely, we need to find fx minus gx first. Fx is given by 4x cubed. Since a is 13, we have plus 13x squared plus 8x plus 15 minus gx. Yeah, make sure you have a bracket here. The negative has to be distributed later. G of x is x squared. B is 9, so plus 9x plus 18. Okay, expanding this, we need to open this bracket. We have 4x cubed plus 13x squared plus 8x plus 15 minus x squared minus 9x minus 18. Collecting like terms, we have 4x cubed plus 12x squared minus x minus 3. We need to factor this. One easy way to factor is, since there are 4 terms, we see whether we can group or not. Let's look at these two. From the first 2 terms, common factor is 4x squared. So we have x plus 3. For the last 2 terms, we can factor out a -1 and we have x plus 3. Now look at these 2 terms. We have x plus 3 as a common factor. We can factor x plus 3 and we have 4x squared minus 1. This is a difference of squares. 4x squared minus 1. This is the square of 2x minus 1 squared. Since we have a difference of squares, we can factor these to 2x plus 1, 2x minus 1. Hence, fx minus gx is factorized completely. D, you need to solve the equation that f of cosecant theta minus g of cosecant theta equals 0 for theta in between 0 and 2 pi. Well, fx minus gx, meaning that x is cosecant theta. And fx minus gx can be factored into this part. So the left side of this equation is just x plus 3, 2x plus 1, 2x minus 1, with x replaced with cosecant theta. We have cosecant theta plus 3, 2 cosecant theta plus 1, and 2 cosecant theta minus 1 equals 0. We set each of these to 0. So from the first term, cosecant theta is negative 3. When we set this to 0, we bring the positive 3 over and we get negative 3. Cosecant is the reciprocal of sine theta. You have to convert all these secondary trig ratio back to the primary. So 1 over sine theta is negative 3. Then from here, sine theta is negative 1 over 3. Sine is negative in quadrant 3 and quadrant 4. That is where the terminal arm lies. So either quadrant 3 or quadrant 4, we find a reference angle, which is inverse sine. Grab the positive value. It must be a positive value since it's a reference angle. It is acute. Using radian mode in your calculator, we have 0.34. In quadrant 3, theta is pi plus the reference angle. In quadrant 4, theta is 2 pi minus the reference angle. So that is 3.48 and 5.94 for theta. That is the first one. The second one, we have 2 cosecant theta plus 1 equals 0. So that 2 cosecant theta is negative 1. Cosecant theta is negative 1 over 2. But because cosecant is the reciprocal of sine, sine theta is negative 2. Just flip the right side and you're good. But that is impossible. Sine theta is always in between 1 and negative 1. It cannot be negative 2. So we do not have a solution for this part. Then we look at this last part. 2 cosecant theta minus 1 equals 0. Isolating cosecant theta, we have cosecant theta equals 1 over 2. Converting back to sine, sine theta equals 2, which is greater than 1. This is impossible as well. So the only solution that we have is 3.48 and 5.94.